you're welcome to today's class, special science class. We're looking at these concepts: position, distance, and displacement. I want you at this time to forget everything you have heard about physics. It's difficult, physics is hard. I'm telling you, all of you, that physics is very easy. We're going to take the concept Coco. Now, the first thing to do is to know what's the meaning of the word position. So, what's the meaning of the word position? If you look at the word position, it's talking about the location of a body. Position in physics is simply the location of a body with relative to the point of origin. I take that again. Position is the location of the body relative to the point of origin or the point of reference. Now, if you look at position, distance, displacement, they are measured using the 1D, 2D, and 3D. Now, what's the meaning of 1D? 1D means one-dimensional space or motion. One-dimensional space or motion. That's 1D. When you talk about 2D, two-dimensional space or motion. When you talk about 3D, that is three-dimensional space or motion. Whichever of these can be used as a method to find position, to find distance, to find displacement. Whenever we talk about the 1D, pay attention to what I'm saying. When we talk about the 1D, you are talking about either the x or the y axis. If you go to the coordinate system, something like this, coordinating system, just like this, your friend will have the x, the y, and the x. This is the positive and this is the negative. When you talk about position, in one-dimensional space or motion, you are talking about using either the x or the y or any of those. Now, if you talk about the 2D, you are talking about the x and the y axis. You are talking about the x and the y axis. If you are talking about the 3D, you are talking about x, y, and the z axis, which we're going to be discussing in this class. Again, position is simply the location of a body relative to the point of origin. Let's take that again one more time. Position is simply the location of a body relative to the point of origin. Let me pick up the ball at the side. We want to take the 1D, one-dimensional space or motion method of solving solutions or problems to position. Let's say we have the one-dimensional space, which is the number line. This is the number line. In this number line, we have the point of origin, which is 0. Over here on the right-hand side, we have 2, or let's say 1, we have 2, 3, 4, and then we have 5. And over here, we know we have the -1, -2, -3, and until infinity. Let's say we have a guy that is standing here. We have another guy, or a lady, now, so we don't cheat any of those. A lady that is standing here. Now, this is the boy. The boy, what position is the boy located? This is the girl. The girl, what position is the girl located? What position is the boy located? Now we see that the boy is located 4 units. to the right. The boy is located 4 units to the right. And the girl is located in -2 units to the left. And you can see how to find position of the body using one-dimensional space or motion. It's very easy to find. Let's do one more. And I will move to the other one, 2-dimensional space or motion. And look at this one here. Let's say we have the number line. And this number line, remember, a 1D-dimensional space is a straight line expression. Let's do that now. Let's say we have this point over here, 0. This is 2, this is 4, this is 6, this is 8. And this is -2, -4, -6, therefore -8. Let's say this guy is standing somewhere here. Another guy is standing somewhere here. Now, we want to find the position of the girl. We want to find the position of the boy. This is the girl, this is the boy. Now, for the girl, look at the girl. She's standing 6 units to the left. Let's use this case. So the girl is standing -6, not just 6, -6 units to the left, while the boy is standing in 8 units to the right. Now you can see how to find position in one-dimensional space or motion. I'm going to play up this now so that we can deal with 2-dimensional space or motion, which we call the 2D. So I'm going to be writing 2D, just 2D. 2D means 2-dimensional space or motion. Now we have the coordinate system. We have the X, we have the X, we have the Y, we have the Y, positive and negative. How do we find the position of A? And A has, let's say, 4 and let's say 10. This is a body, not 2 bodies, just 1 body. But it's standing on 2-dimensional space on 4 and 10. X, 4 to the X, and then 10 to the Y. That is the position of this young man or a beautiful girl. Now, let's say, how do we find this? This is positive, this is positive. I'm going to start from here. So you see, I draw out to my x-axis. Don't measure the line, draw the line. When you draw the line, you'll stop at anywhere. So far you can calibrate your illustration. Now, if it's the Y is positive. I will tell you why we are moving towards the vertical line up, because the Y is positive. Assuming the Y is negative, we are going to go down. So now the Y is positive, we're moving on. Let's calibrate the X. Where is the X? This is my X. So I have 2, I have 4. Now let's calibrate the Y. The Y, we have 2, we have 4, we have 6. Let me pick it more up again so we can have more space. We have 8, we have 10. You join the line between 4 and 10. Let's take it up 1, 2, 3, and then we have 10. You see? So we get it like this. This is the position of the boy or the girl. Let's do one more. Let's say we have another guy. Remember, we are doing the 2D now. Let's say we have another guy. This guy, B, is standing on, let's say, 8, and let's use the minus sign here, minus, let's say 10. All right, now, look at the coordinate system. The X, usually the first one is the X, the second one is the Y. Now the X, we're coming like this. All right? We're coming like this. So this is the point of origin. Now the Y, we're going to go down because of the negative value. So we have it like this. So what do we have? This place becomes my, let's call this 2. Let's call this 4. Let's call this 6. Let's call this 8. Now, this place becomes negative 2, negative 4, negative 6, negative 8, negative 10. Now let's join the negative 10 to the positive 8. We're going to come down like this, and then we'll join to this place. And then when you through, you join the resultant vector. Now this is the position of this person standing on 8 and 10. I'll give you some as an assignment. Do that and drop it on the comment section. Let's say we have C, and C is standing on the position -8 and minus 16. You can do that and drop it on the comment section. Let's now move on to the next thing. The next thing is distance. You know, we're not going to do the 3D. We separated that one for a specific video. A special video is for that, where we'll discuss 3D of position, 3D of distance, 3D of displacement. We want to take this concept little by little, so that you can get the full comprehension. Too much knowledge, too much information leads to loss of information. So you understand number line of position, you understand 2D, 2-plane of X on the Y axis. So let's go to distance. What's the meaning of distance? Now, if you're asked what distance is, you don't need to stress yourself. Forget about the physics gibberish. What I mean by the physics gibberish is when they will come, a person that is a prof or a pro in physics, and they begin to tell you distance is defined as a point between two bodies without relative to the starting point and the ending point. All those things, we can summarize it just in a sentence. Forget about what I said. We'll summarize in one sentence. Distance is the gap between two bodies. That's okay. You don't need to cram that. Distance is the gap between two bodies. All those physics gibberish, leave that alone. Now, if distance is a gap, but the other you can say is the length between two bodies, that's also good. But the major one to remember is the gap between two bodies. So let's take distance under 1D. Distance is a scalar quantity, and in scalar quantity, we have magnitude, but we have no direction. When someone is a scalar quantity, when something is a scalar quantity, he has magnitude without direction. Let's take distance under the 1D. 1D means a straight line. So let's do that now. We have the number line now. The number line, we have the point of origin 0. We have this to be 2. And let's start with 1, 2, 3, 4, 5. This is -1, -2, -3. Let's say this guy is starting up from here, and then he moved to the side, and then he moved back to the side. What is the distance covered? Distance covered is 1, 2, 3, 4, 5, 6, 7. 7 units to the right. 7 units to the right. I told you distance, you don't need positive or negative. It's always positive. So distance is always plus. There is no negative there. Whether you're going to the side, or you're going to the side, any other side you're going to the side, going to the other side is always positive. Now we have these to be 7 units. Now we're going to the other side. As we go to the other side, you count the units that is therein. Now we have 1, 2, 3, 4, 5, 6. This guy moves 6 units to the left. Now distance is simply the addition of them two. Distance is simply the addition of them two. Then we have into 7 plus 6. Of course, 10. We have 2, 13. So what should be having is 13 units. Now, this is how to find the distance on one plane. Remember, should I do one more? You don't need one more. This is very easy. Just count the number of units that you have, and then count the number of units added together. For instance, let's say I move from here to here. Let's call it 8 meters. Then when I got here, I moved back from here. I moved back. I'm moving forward or backward. I moved this place here, 8 meters. Now, you see, I moved here. I came back. And then it's 8 meters. My distance covered is 8 plus 8. And 8 plus 8 is 16 meters. That is very easy to understand. You don't need to bother yourself on the addition or the subtraction for distance. But when you get to displacement, you need to be careful in that part. Let's go to location, how to determine the distance of the body using the 2D dimension. So for the 2D dimension, you need to pay attention to this one, because this one needs a mathematical approach to it. So we need to solve a problem, some problem in it. Let's say the calculate the distance from the school A, which is 4, let's say 4, and let's say 3. Calculate the distance from the school 3 and 4 to your house or to the staff room. To the staff room. Distance of the distance from the school to the staff room. Now, if you say school staff room, it's somehow complicated. Let's say classroom here. This is classroom. I think this makes more sense. Calculate distance from the classroom, which is A, this, to the staff room, which is B. So this is B now. So we have B to be, let's call it 5, and let's call it 12. Now, how do you solve this? Solution. Draw a line. Now, the solution to this is that we need to bring out the values, the parameter. Now, we know that the formula to use is x, which is equals to the distance, all squares of x2 minus x1 plus y2 minus y1. Then you go with it. Are you clear now? Now what you do? What you do is now, which one is the x2, y2, whatever. Now the x2, let me show you. Let's start with x1. This is x1, y1, x2, y2. Now let's look at the value. X1 is 4, Y1 is 3, X2 is 5, Y2 is 12. Now, let's make a space for ourselves here so we can solve. Now, how do we solve that? Just pay attention to what I'm saying. Now we have an X all squared. What's my X2? What's my X2, yeah? X2 there is 5. So I have 5 minus, what's my x1? x1 there is 4, minus 4, all squared. Remember, you're going to put a square there, sorry for that. There will be a square, all squared, plus, what's your y2? y2 there is 12. What's your y1? y1 there, y1 there is 3. So, all squared. Now let's use the calculator now. We still have the value to the x is equal to all squares of 5 minus 4, which is 1 raised to the power of 2. 1 raised to the power of 2 is still 1, plus 12 minus 3, that is 9. Okay? 9 raised to the power of 2. Then we have s, which is equal to all squares. 1, this is 1, then this should be 81. Let's just confirm it. 9 to the power of 2. I'm coming. That should be 81, but 9 to the power of 2 is 81, correct? So this is 81. This plus this is 92. So what's the square of 92? The square of 92 is about 9.59. All right? So this is how to solve that video, that question. Let's write. No. I'm sorry. This is 82, not 92. I'm sorry for adding something to it. It's 82, not 92. So 82 squares of 82, that is 9.05. Okay, now let's make it just to 2 decimal places. 9.06. Let's call it meters. Now, this is the distance from the classroom to the staff room using the 2D, the two-dimensional space. I'll give you a question and I expect you to solve it and drop it on the comment section. Because I will learn. We learn by working, by doing. Practice makes you perfect, they say. So take this question, solve it, drop it on the comment section. Take the step we took here, you will get your answer. Calculate the distance from your house A minus 4 minus 8 to the church. So the church, and the church is B, which is equals to 10 minus 10. So find the distance from your house, which is minus 4 minus 8, and the church, which is 10 minus 10. I will help you, because I will help you. Let me just solve. Use the same method we use, but let me give you just an insight. This is x1, y1, x2, y2, all the time. Alright, so solve that problem, drop it on the comment section, and I will get back to you. So let's look at displacement. Let's look at displacement. But meanwhile, you can have distance on 3 planes. But let's look at displacement because of the scope of what we are to study today. So displacement, what is displacement? Displacement is change in x, which is equals to the x final minus the x initial. What's the x final? X final is equals to the final displacement. The x initial is equals to the initial displacement. So whichever one you're still on track. Now let's say what is displacement? Now if you're asked that, just say displacement is simply a change in position. You see, if you want to be very accurate in definition, you don't need physics gibberish. You don't need those gibberish. Just find the simplest term to define it. I told you position is a location of a body. Anyone can remember that. Position is a location of a body, but relative to the point of origin, the point of origin on the number line. And I told you distance, a gap between two bodies. Then displacement is just a change in position. Change in position. Let's look at displacement under the 1D. Displacement under the 1D. Now, under the 1D, which is always a straight line, number line. So we have the point of origin, here 0. So we have minus 2, minus 4, minus 6. Let's say here 2, 4, and 6. These guys start from here, and then walk towards this side, and then walk towards this side. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He walked 10 units to the right. So we have 10 units to the right. Now this guy walked 1, 2, 3, 4. 4 units to the left. But meanwhile, we will not use this calibration to solve. We will use this formula to solve the problem. I just remember that we are dealing with displacement, not distance. So let's focus on displacement. On displacement, we'll be using change in x, change in f, minus change in r. Change in the final position minus the initial position. Now from here, which one is the final position? Look up at the board. Which one is the final position? If you want to get the distance, let me make an illustration. Distance is, the distance b, for instance, is just 10 plus 4. So 10 plus 4 is 14. That is distance. But for displacement, change in x is equals to x final minus x initial. Now, what's the x final? Minus 2. Minus, what's the x initial? Minus 4. Whenever minus it will cancel out. We have minus 2 plus 4. And minus 2 plus 4 is equals to 2. So that is 2 meters. In terms of displacement, these things are very easy. Now, we are going to do one more before we go to displacement on the 2D. So let's have this. So let's have this now. Let's say we have another position, stuff like this. And then we have this 0, 2, 4, 6, minus 2, minus 4. These guys started here, okay? Traveled to this place, and then traveled back here. Now, what is the displacement of this guy? I want to show you something. Just look at me. I am standing here right now, and I move towards the end of the college, and I move back to the place I am standing. Do you know that there is no displacement? Yes, there is no displacement. But if it's distant, the length cover for the first one, the length will add to the length cover for the second one. But for displacement, change in position. Now, as I've walked forward and came back to my normal position, is there any change in position? That's the question. There is no change in the position. So, the guys started x final minus x initial. X final there is minus 4. Minus final initially, sorry, x final is minus 4. X initial is minus 4. We have minus 4. Minus will cancel minus. What we have will become minus 4 plus 4, which is equals to 0. So we see that. That's the same factor that we are using here. Now we are told x final here is 2. X initial is 4. Very easy. And then you solve it. Let's solve displacement on the 2D. Displacement on 2D. Now for the 2D, let's give you a question for that. Now let's say a vehicle or a car, say a car, traveled 3 kilometers to or due east and 4 kilometers due north. Calculate the displacement of the car. Okay, we have this. A car traveled 3 kilometers due east and 4 kilometers due north. Calculate the displacement of the vehicle. Now, just look at the board. If you understand what we mean by the coordinating system, like this. This is your north, this is your south, this is your east, this is your west. Now, this guy is traveling 3 kilometers to the east. This is 3 kilometers. And then he traveled 4 kilometers to the north. This is 4 kilometers. Now, what is the resultant vector here on the displacement? Look at it. What's the displacement of this guy? Now, normally, you're going to use Pythagoras to solve the problem. For me, why? I don't like using Pythagoras for this problem. There is another formula to use. You know, talking about triangle. Now we have that. Let's cut that out. We have this now. This guy is 3 kilometers here, and then 4 kilometers here. So now, what we do? I have a formula F is equals to all squares of f of x plus f of y. Are you following that? Now, this is the formula I love to use. Now, using these formulas, or you use c squared is equals to a squared plus b squared. You can use that. Any of those. Now, the one you are familiar with is this guy. Are you still with me now? Now, if we try now, I think this one we have square and square. Let's use the 2 and see what we will arrive at. Alright? So let's say this one, f, is equals to, this is 3 raised to the power of 2 plus 4 raised to the power of 2, which will give you f is equals to, this is 9, this is 16, which will give you f is equals to, all squares, this plus this is 25, then square root of 25 is 5 kilometers. If you use this same formula, you will get the same answer. Are you still there? You can try that. Then, for the angle of displacement there. The angle of displacement, I love to use theta is equals to tan inverse. But let me not clean up my situation. Let me find that. Yeah, theta is equals to tan inverse of f of y minus f divided by f of x. That's what I love to use. But there's other method to solve it in case you don't love this one. Okay? Now, you can use SOHCAHTOA. You can use SOHCAHTOA to solve it and get the term and then find what is there. Okay, whichever one you want to use, I prefer using this one. So my theta is equals to the tan inverse. What is my y? The y-axis. Look at it. This is the y-axis. This is the x-axis, which is 4 over the x-axis is 3. So the tan inverse, theta is equals to the tan inverse of 4 over 3. So what is 4 divided by 3? So 4 divided by 3 is equals to 1.333. So let's find shift tan. Shift tan, that's tan inverse, 1.333. Now that's going to give me the angle of 53.12.